all, in graph theory, you will learn about a simple graph. So, what do you understand about a simple graph? You need to know that in a simple graph, there is no loops and no multiple edges. The sum of degrees in a simple graph is twice the number of edges. There are three things that you need to identify in a network graph. First, V, the set of vertices or dots. E, the set of edges or lines. And D, degree, the number of edges that connect two vertices. So, let's try an example. Based on the graph given, we need to determine A, vertex, and number of vertex. So, the vertex are A, B, C, and D. And number of vertex is 1, 2, 3, and 4. B, determine edges and number of edges. So, the edges are AB, AB, AC, BC, and CD, C and D. And number of edges is 1, 2, 3, and 4. So, the sum of degree is equal to edges multiplied by 2, the number of edges multiplied by 2. So, here we got 2 times 4 equal to 8. Okay, next, graph with multiple edges and loops. Okay, so what is multiple edges? So as you can see, this is the multiple edges. And multiple edges involve two vertices, and the vertices are connected by more than one edges. The sum of degree is twice the number of edges. Next, loops. Loops, as you can see here, this is the loops. And loops only involve one vertices. The edge is in the form of an arc that starts and ends at the same vertex. It starts and ends at the same vertex. So each loop adds 2 to the degree. And, okay, based on this diagram, determine the V vertex. So the vertex is E, F, G, and H. The number of vertex is 4. So the edges is FE, FE, which is FE, multiple edges, FE, FG, GH, GH, and loops, HH. Here is the loops. And number of edges is 5. So the sum of degree is equal to edges multiplied by 2. So you get 2 times 5 equal to 10. So now, let us differentiate the differences between directed graph and undirected graph. First, let us see the differences in simple graph. So simple graph is a graph without loops and no multiple edges. In undirected graph, the vertex is A, B, C, and D. And in the graph, the vertex is also A, B, C, and D. But for the edges, in undirected graph, the edges is AB, AB, AC, BC, BD, and CD. Note that the order of V is not important. So, which means you can write either AB or BA, AC or CA, it doesn't matter. But in directed graph, you need to write the vertex written should be according to the direction of the edges. So here AC, AC, BA, BC, BD, and CD, because the order of V need to be written in according to the direction of the edge. Now let's look at the degree. The degree for A is 2. 1, 2. Degree for B is 3. 1, 2, 3. Degree for C is 2. 1, 2. And degree for D is also 2. 1, 2. So the sum of degree is 10. The degrees that goes in for A is 1. 1. And the degrees that goes out for A is also 1. Here is 1. Degrees that go in for B is 0, and degrees that goes for B is 3. As you can see, all goes out. 1, 2, 3. Degrees that goes in for 2 for C is 2. 1, 2. Degrees that goes out for C is 1. 1. Degrees that goes in for D is 2. And no degrees goes out from D. 1, 2. So that makes the sum of degree is 10. Now let's look at the differences with loops and multiple edges. Okay, so under the graph, the set of vertices is A, B, C, D, and E. The set of edges is AB, AE, BC, BE, CC, CD, again CD because it's multiple edges, DE, and loops EE. So the degrees for A is 2. 1, 2. Degrees for B is 3. 1, 2, 3. Degrees for C is 5. C, because it is loop, so clockwise and anti-clockwise. 1, 2, 3, 4, 5. Degrees for D is 3. 1, 2, 3. Degrees for E is 5. Again loop. 1, 2, 3, 4, and 5. So that makes the sum of degree is 18. So here direct the graph. The set of vertices are A, B, C, D, and E. A, B, C, D, and E. And the set of edges are, let's start with A. So A goes to B. We write here AB. B goes to E. Here BE. C goes to B, so we write CB. C loop here, so CC. C goes to D, and D goes to C. E goes to D, so we write here ED, and another loop E, and lastly EA. Subgraphs and tree. What is a subgraph? Subgraph is a part of a graph or a whole graph redrawn without changing the original positions of the vertices and edges. Here is the original graph. So diagram A, vertices A, B is a subgraph of original graph. Diagram 2, edges AB is a subgraph of original graph. Diagram 3, edges A and vertices B is also a subgraph of the original graph. And diagram 4, edges A, B, C is a subgraph of the original graph. This is a part of the original graph. And also diagram 5, this whole diagram is also the subgraphs from the original graph. Tree graph. So tree graph is a subgraph of the graph with the following properties, which is it is a simple graph. It is also has vertices that are all connected, and each pair of the vertices is connected by only one edge. The number of edges must be equal to number of vertices minus 1. Determine whether each of the following is a tree. So first, this is not a tree. Why? Because it has 3 vertices and 1 edge, which does not follow the properties of a tree graph. A tree graph should have number of edges that is equal to vertices minus 1, and the vertex V is not connected to other vertices, whereas it does not follow the properties, so it is not a tree graph. Next, this is a tree because it has 4 vertices and 3 edges, which follow the properties that number of edges must be equal to number of vertices minus 1, and each pair of vertices is connected by 1 edge only. Lastly, as you can see, this is not a tree. Also again, it has 4 vertices and 4 edges and does not follow the properties of a tree graph, and each pair is connected by more than 1 edge. That is all for Network of Graph Theory. Thank you.